Hello everyone, welcome to this video on Poisson distribution part 3. We have already covered part 1 and part 2. We have found the basics of application of Poisson distribution in it. We will move on to one more level ahead in this video. Quickly moving on to the problem. The problem says it is known that the probability of an item produced to be defective is 0.05. If the produced items are sent to the market in packets of 20, find the number of packets that contain no defective, exactly 2 defective, at most 2 defective items in a consignment of 1000 packets. So on reviewing the question, we don't have any keywords of what type of distribution the problem follows. Like there is no mentioning of the word binomial or Poisson. So how to deduct or identify what distribution to apply for? So now let us look for the keywords which is appearing over here. The probability of the item to be defective is being given as 0.05. The next thing is that it is sent to the market. The number of items produced are sent to the market as a packet of 20. So, and the third word is given is you have a consignment to hold 1000 packets. So we will take on these clues to see what can be effectively derived from the data given. Probability of success P has been given as 0.05, and you send the items in a packet of say 20. So the number of items in the packet is going to be equal to 20. Now n is equal to 20, so less than or 20 means you can apply binomial, and greater than 20 means we can apply Poisson distribution. But it is equal to 20, in which case both binomial and Poisson can work one and the same like. Now let us go to the second clue, P equal to 0.05, which moves towards 0. So it is going to be something like an highly impossible even. So when the value of P tends to 0, we know that we will have to go with Poisson distribution. So this is going to be the right clue for us to decide the problem follows Poisson distribution. So once we now fix it is going to be Poisson, let us recollect the formula for Poisson as e power minus lambda, lambda to the power of x by x factorial, varying for x from 0, 1, 2 up to infinity. Now these two data are okay, and what about this third data? Now you are sending the packets as a consignment, like whole lot, and this whole lot as packets like this, and each of the packets has 20 in them. So how many such collection of packets we have? Such collection of packets is going to be 1000 in number. So this quantity which we have over here, 1000, is nothing but the representation for our capital N, and this value over here, this now represents our small n. So we have been given small n as 20 and capital N as 1000. And secondly, we know identify that we have been given a keyword number of packets. So whenever we need the number of packets, keep in mind here the number of items or number of packets is given by the formula capital N into probability of x. So now what happens over here? You find the individual probabilities for individually each of these cases, and to get the number of packets, then you will have to multiply it with 1000, because this probability which you are estimating is only for this one such small packet, but you are sending it as a consignment. So in this whole of the consignment, how many such packets will be there with such a kind of defective is what we have been asked to find here. So keep in mind the number of items is always given by capital N into probability of x. So without failing, after finding the individual probability, you will have to multiply the probability with n, and our n has been given as 1000. So now we will move on to fix the remaining quantity. What is the only thing required for a Poisson distribution? It is going to be the value lambda, but nothing has been said about lambda over here. So we go for the formula lambda equal to n into p, in which case n is going to be 20 and p is going to be 0.05. 20 times of 0.05, that makes lambda as 1. So lambda value is now arrived at as 1. So taking lambda equal to 1, we are going to start working on the problem. First problem, so let us fix the random variable as x be the number of defectives in a packet of 20. Okay, so let x be the number of defectives in a packet of 20. So it contains no defective. So what is going to be the first question all about? The first question asks us probability you have no defective, so x equal to 0. So it is e to the power of minus lambda, lambda to the power of x by x factorial. Keep in mind anything power 0 is 1 and 0 factorial is also 1. 0 factorial is 1. So what we need is just e power minus 1, which can be evaluated using your calculators. E power minus 1 now gives the value as 0.3678. This is the probability for one packet. Therefore, for 1000 packets, the number of packets to have no defective will be given by 1000 into the corresponding probability. What is going to be it? 1000 into 0.3678. So now this gives us 367.8. You cannot have 367.8 packets, so round it off to the nearest number. So you will have integer giving you 368 is more than 1, so you add up 1 to the next number, so this becomes 8. So you have out of 1000 packets, number of packets to have no defective will be 368 packets. Now moving on, the second question asked us exactly 2 defective. So what is the next thing which we need is subdivision to exactly 2 defective. So this is e to the power of minus lambda, lambda to the power of 2 by 2 factorial. So this is going to be equal to e to the power of minus 1 divided by 2. Go estimate your value for e of x equal to 2. So this will give me 0.3678 by 2. This gives the value as 0.1839. So now this is going to be the probability for one packet with n equal to 20. Therefore, if we have 1000 such packets, for 1000 such packets, the number of packets that have exactly 2 defective will be equal to the number of packets that contain exactly 2 defective will be capital N into probability of x. So this will be 1000 times of 0.1839. So when you are going to multiply it, what will be the answer? 183.9. So this again has to be rounded off to the nearest integer. So you will have 189 is more than 5. So you give 1 over here, 184 packets. So out of 1000 packets, for 1000 such packets, number of packets to contain exactly 2 defective will be 184 packets. Let us move on to the last subdivision. What was the last subdivision? You want at most 2 defective. So what is going to be at most 2 defective? So you want at most 2 defective. So this is nothing but probability of at most meaning maximum. So x has to be taking 2 as the maximum value, so it can take values less than or equal to 2. So this is the case where we will have to go and add all the probability less than 2. So x takes the value 0, 1, 2 up to infinity. So what are the numbers less than or equal to 2? So moving over here, the numbers are x equal to 0 plus x equal to 1 plus x equal to 2. We have already got the answer for x equal to 0 from our first subdivision, and this is going to be 0.3678. The answer for the last part was got from your second subdivision as 0.1839. And for this x equal to 1, it is nothing but e to the power of minus lambda is 1, 1 to the power of 1 by 1 factorial, which is the same as e to the power of minus 1, 1 to the power of 0 by 0 factorial, because this is also 1 and this is also 1. So now identifying the same, you can take this also to be 0.3678. So add up your data. So addition of all the 3 will give you 0.1 0.9195. This is the probability of arriving at most 2 defective in a packet of n equal to 20. So for a packet containing, therefore for 1000 such packets, the number of packets to contain at most 2 defective will be equal to capital N into probability of X. So this is going to be 0.9195, the probability, multiplied by N. N is going to be equal to 1000. So when you multiply it, you will have it as 919.5. So this cannot be number of packets because decimal cannot happen in number of packets, so round it off to the nearest integer. So that makes it as 5, which is greater than 1. So you give 1 over here, 9 will become 0, so it carries on 1 over here. So 919.5 makes it as 920 packets. So having completed that one, we will move on to the next problem. A car hire firm has 2 cars which it hires out day by day. The number of demands for a car follows Poisson distribution with mean 1.5. Calculate the proportion of day on which neither car is used and some demands are fulfilled. This is going to be a direct question for you students because you have been given that it follows Poisson distribution, and it is going to be having a mean value going to be 1.5. So you can directly go with it. So X follows Poisson distribution. So probability function is e power minus lambda to the power of x by x factorial, valid for x varying from 0, 1, 2 up to infinity. Now we have been given mean of the Poisson distribution is the same as lambda is given as 1.5. So what you have over here is the car hire firms has how many cars? It has 2 cars. So what is happening over here? Neither car is used. So let x be the random variable that demands or is denoting the number of cars used in a day. So what happens in our first division? Neither car is used. Both of them are in the same shed. None of them is moving out. They are both held in shed itself. So you have 0 cars to be used. So this is going to be e to the power of minus 1.5 to the power of 0 by 0 factorial. Anything power 0 is going to be 1, and 0 factorial is also going to be equal to the same as 1. So you just have to estimate e to the power of minus 1.5 using your calculators, which you can get it as 0.2231. Moving on to the second subdivision, some demands are not fulfilled. When you have not fulfilled your demands, when you say that there is going to be a case where you can't provide them with a car. When you can't provide them with a car, when both of them have gone out of shed. So both of them have gone out of shed, you have no car over here to provide. So you can say that the demands are not fulfilled. In which case the probability is x is equal to the demands are going to be more than 2. Okay, so you say not fulfilled, you don't fulfill them because the number of demands you get is going to be more than 2. Number of cars used is already 2. You want to be number of demands is more than 2. So if the demands are more than 2, you are not fulfilling the demands. So keep it in mind. So how to find this? This is going to be from 2 to infinity. So take the complement of x less than or equal to 2. In which case you have 1 minus probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Use your calculators to estimate these datas. So you can find the value to be equal to 0.1913 when you estimate this, and fix your lambda to be equal to 1.5. Thank you.